Dear students, welcome to 10th class Real Numbers Part 2. Today, first we learn about composite numbers. Composite numbers. You know that every number has at least two factors. They are one and itself. If numbers having more than two factors, that means one and itself, then that numbers are called composite numbers. Simply, composite numbers are having more than two factors. Example 15. 15 is equal to 1 into 15, 1 into 3 into 5. So 15 having more than two factors. They are 1 comma 15 comma 3 comma 5. That's why 15 is called composite number. Again 18. 18 is equal, simply you can write other than 1 and itself 2 and 9. So 18 is also composite number. In our textbook, we have based on composite numbers problems. So first we can take one problem. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Solution. First problem 7 into 11 into 13 plus 13. Here 13 is common factor. So take common 13. Remaining are 7 into 11 plus 1. Here 13 into 7 into 11, 77 plus 1. So 13 into 78. So it is composite number. Composite number. Composite number. Now take second problem. Here 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. You can observe that 5 is common in both numbers. So here is 5, here is 5. You can take 5 as a common factor. So write 7 into 6 into 4 into 3 into, of course 2 into 1 is 2 plus 1. So the given number is the multiple of 5. So simply you can write as composite number. Otherwise 5 into 7 6 are 42 into 4 3 are 12, 12 2s are 24 plus 1, that is equal 5 into 42 into 24 is equal to 1008 plus 1, that is equal to 5 into 1009, that is equal composite number. So if numbers having more than 2 factors are simply called composite numbers. Students, we will next enter the next topic in this chapter, rational numbers. Rational numbers. Rational numbers are in the form of P by Q. P by Q, where Q is not equal to 0. P comma Q are integers. P comma Q are integers. Now on the based on the prime factorization of Q, rational numbers are converted into terminating decimals and non-terminating decimals. If Q is in the form of 2 to the power of n, 5 to the power of m, where n comma m are integers, where n comma m are non-negative integers. N comma m are non-negative integers. If Q is in the form of 2 to the power of n, 5 to the power of m, P by Q is terminating decimal. Terminating decimal. If P by Q is, in the P by Q, if Q is not in the form of 2 to the power of n, 5 to the power of m, is not in that form, it is non-terminating decimal. Simply rational number in the form of P by Q, it is two types: terminating decimal, non-terminating decimal. In terminating decimal, Q is in the form of 2 to the power of n, 5 to the power of m. Q is not in the form of 2 to the power of n, 5 to the power of m. Here n comma m are non-negative integers. Students, I think you have understood the concept. Simply you can factorize the denominator of the rational number, and if the denominator is in the form of 2 to the power of n, 5 to the power of m, it is terminating decimal. If q is not in the form of 2 to the power of n, 5 to the power of m, it is non-terminating decimal. Based on this concept, we will try to solve few problems. First model, write the following decimals, write following rational numbers in their decimal form. By using division. First, 3 by 8. Here, simply you can divide 3 with 8. So 3 is the smaller than 8. Put 0 in the quotient and put decimal, write 0. 8 3 is 24. Now 30 minus 24, 6. Save. 0. 8 sevens 56. 4. 0. 8 fives 40. So 3 by 8 is equal 0.375. It is terminating decimal. Now take one more example. Second problem, 2 by 11. Divide 2 with 11. So 2 is the smaller than 11. Put 0 here and put decimal, write 0 here. 11 ones 11. 9. 0. 11 eights 88. 2. 0. 11 ones 11. 9. 0. 11 eights 88. So this division is continue. There is non ending. This is called non-terminating recurring decimal. So write 2 by 11 is equal 0.1818 so on. That is 0.18 bar. Non-terminating repeating or recurring decimal. Try to solve yourself by taking some more examples. Now we will take one more model problems regarding this topic. Here we can uh, state the given numbers are terminating decimals or non-terminating decimals or non-terminating repeating decimals by without performing division. So, second model, without performing division, state whether the following rational numbers will have terminating decimal form or a non-terminating repeating decimal form. First one, 13 by 3125. It is a rational number. It is in the form of P by Q. Now we can justify which this number is terminating decimal or non-terminating decimal without performing division. So you can write the denominator 3125 in the form of prime factorization. So 3125, 5 6 are 30, 5 2s are 10, 5 5s are 25. Again 5 1s are 5 2s are 5 5s are. Again 5 2s are 5 5s are. So 5 5s are. 3125 is equal to 5 into 5 into 5 into 5 into 5. We have 5 5s. So 5 to the power of 5. So 3125 is in the form of 2 to the power of n, 5 to the power of m. Here n is equal to 0. N is equal to 0. 3125 is equal to 2 to the power of 0 into 5 to the power of 5. Here 2 to the power of 0 is equal to 1. So 3125 is terminating decimal. Terminating decimal. Now we will take one more example. 11 by 12. 11 by 12. 12 means 4 into 3. Otherwise, you can prime factorization 12. 2 6 are 12. 2 3s are 6. Means 12 is equal to 2 into 2 into 3. Here 3 is other than 2 and 5. In the prime factorization of 12, we have another number other than 2 and 5, that is 3. So it is non-terminating repeating decimal. Non-terminating repeating decimal. Another words, recurring decimal. Now we will take one more model in regarding this topic. We write the following rational numbers. Following rational numbers in decimal form without performing division. First problem. 23 by 2 cube into 5 square. Students, you have understood in denominator factors are only 2 and 5. So it is terminating decimal. So we are able to write this one is in the form of decimal form. Here the power of 2 is 3 and power of 5 is 2. First we can equate the powers of both the factors. So simply I am writing 23 by 2 cube into 5 square. Multiply the both denominator and numerator into 5. So 23 into 5 by 2 to the power of 3 into 5 to the power of, here 5 to the power of 2 and here is 5 to the power of 1. 5 to the power of 2 into 5 to the power of 1. So the bases are equal and we are multiplying these factors. So you can add the factors. 5 to the power of 2 plus 1 is equal to 5 to the power of 3. So write 3 here. And here 23 into 5 is 115. Again, you can write 2 into 5 whole to the power of 3. So 115 by 2 5 is 10 cube. 115 10 cube means 10 into 10 into 10. So 115, 10 tens are 100, 100 tens are 1000. So in the denominator you have 3 zeros. Simply you can put the decimal form after 3 digits. Count from ones place to starts from ones place. So 5 1 1. Simply you write this one 0.115. Next, we will discuss this model another problem also. 143 by 110. First, we will try to factorize the denominator 110. 5. 5 is a 10. 5 is 10. No. 5 2s are 10. 5 2s are 10. 5 2s are 10. Again 2. 2 1s are 2 1s. So the denominator 110 is 5 into 2 into 11. But if it is terminating decimal, it have only the factors 5 and 2. We have another factor 11. So factorize the 143 also. Numerator 143. 11 ones are 11. 11 threes are 33. So 143 is equal to 11 into 13. So 143 by 111 is equal to 11 into 13. Because 143 is the product of 11 into 13. 110 is 5 into 2 into 11. Cancel the common factor 11. So 13 by 5 into 2. 13 by 10. So you have only 1 0. Put after one place starts from the ones place. Decimal starts from units place. So 1.3. The decimal form of 143 by 110 is 1.3. Okay, students, you can practice these problems and try to solve exercise in your textbook. All the best.